All right, let's look over our calc. We're in section 5.3. We're going to do a couple of examples here. I'm going to start with number 2, and I wrote out the whole thing here ahead of time just because I don't want to burn all that time while I'm talking. Anyway, so I should just get to it. So what I'm going to use, I don't know what functions f and h are, but they gave us some values. The area underneath the curve of f of x between 1 and 9 is -1, and so on, and a couple other facts there. And I need to use those facts to answer all of these other questions. And I'm going to do that using the table at the beginning of the book, the table 5.3, page 285. Okay, so part A, well, this is the integral from 1 to 9 of -2 times f of x dx. That's just like this one right here. Okay, so if you multiply an integral by a constant, well, that'll just take -2 times -1. Okay, and I have to make sure that the limits of integration are the same. They are. The function is the same. Everything is the same, except it's just multiplied by -2. So the this integral evaluates to 2. Okay, B, a sum. The integral of the sum is the sum of the integrals. That's one of those facts on page 285. So f of x is 5. H of x is 4, so that'll be 5 plus 4 is going to give me 9. Okay, and yeah, again, you have to check the limits of integration, good, function, good. There's only the plus sign there, so that's the value there for part B. For part C, again, limits of integration are the same from 7 to 9. So let me see, 2 times the f of x value, 2 times 5 minus 3 times 4, 10 minus 12. That's going to give me -2. So this evaluates to -2. Now for part D, they just switch the limits of integration. It goes from 9 to 1 instead of from 1 to 9. They switch those around. Well, according to the table 5.3 on page 285, that just gives you the opposite of this answer. So this will be a positive one instead. Positive one instead. So if you change those limits, it just changes the sign. Now E, well, E from 1 to 7, I don't have anything that matches that. Okay, what I want to look at is that same table, and let me see. Good. It's property number 5. So what I can do is I can say, well, the integral from 1 to 7 f of x dx plus the integral from 7 to 9 of f of x dx is equal to the integral from 1 to 9 of f of x dx. Okay, so I had to write this out. But think about what this is saying. This is saying if you add the area between 1 and 7, or if you take the area between 1 and 7 and add it to the area between 7 and 9, that's the area between 1 and 9. Well, no, duh. It's just taking those two areas and adding them together. Okay, well, now I can solve for this. I can solve for this because this is from 7 to 9. This is 5. And this is, let me see, from 1 to 9, this is -1. Okay, so if I solve for that and subtract 5, this is going to give me -6. -1 minus 5 is -6. So this equals, let me just write it off to the side here. I'm going to run out of room. I should have left myself a little bit more. But I get -6 for the value of that integral. And finally, the integral from 9 to 7. Well, again, they've switched the order, right? So make both of those negative. So h of x between 9 and 7 is 4, so that's -4 minus f of x between 9 and 7 minus -5, and that's going to give me 1. So for f, that just comes out to 1. So that's how you use the properties in that table to get all those values of all those different integrals using the given ones.